Hello everyone. Today we're going to be talking about recursively defined sequences. So we've been working with the explicit form or explicit rule for sequences, which as a reminder, an explicit rule gives an as a function of the term's position number n in the sequence. So we can use this, for instance, if we're wanting to find what 815 was, so the 15th term, we plug in 15 in for n, and we would get what that term was. So for example, an explicit rule for the arithmetic sequence 3, 5, 7, 9 is an is equal to 2n plus 1. So if I were wanting to find the fourth term, I can either look here, but I can plug in 4 for n, and I get 2 times 4, which is 8, plus 1, which is 9. And so I can find it that way. Another way I could have written this out was an is equal to a1, which is 3, plus n minus 1 times the common difference, which is 2. So that's for an explicit rule, but today we're going to be looking at a recursive rule, and a recursive rule gives the beginning terms of a sequence and a recursive equation that tells how an is related to one or more preceding terms. And so here are a couple of things just to keep in mind is that we're always going to state the first term, so there's always going to be two parts to this recursive rule. The first thing that we state is what our first term is, so a1 equals, and then it also requires a formula that relates the nth term to the n minus 1th term. So this formula, it's relating how the next term is related to the previous term. So let's look at our recursive equation for arithmetic and for geometric sequences. So for both of these, a1 again, that is just going to be the first term. An is going to be the nth term. So if I were wanting to know the 15th term, n would be 15. And now for an minus 1, that is going to stand for the previous term. So recursive equation, we see it relates the term we're trying to find to the term before it. And then D here is still going to be common difference. And then a common ratio. So let's look at an example of plugging something in. So let's say I knew what A3 was. Let's say I knew the third term. This recursive equation is going to relate that to the previous term, which when I plug in n, I get 3 minus 1 plus d. Well, 3 minus 1, that just gets me a2 plus d. So my third term is going to be the previous term, which is the second term, plus d. And that's how these are going to work. So let's go through some examples of evaluating. So directions, we're going to write the first 6 terms of each sequence. And so I notice I do have a recursive defined sequence here, a recursive rule, because I have my first term stated, and then I have my recursive rule right here, where I have an minus 1, which is just going to be the previous term, plus 4. So I'm going to highlight that, and I know that's previous term. So I already know a1 is equal to 2. It gives that to me. So I have a2 is equal to, if I plug just 2 in for n, I get a to the 2 minus 1 plus 4, which is equal to 2 minus 1 is a1 plus 4. Well, what is a1? a1 is equal to 2. So I get that a2 is equal to 6. So that's a little bit of a longer way to do it. So a shortcut you can do is just to remember that this term is equal to the previous plus 4. So I'm going to think of it that way. So I have a3 is equal to the previous, which is 6, plus 4 which is equal to 10. So I insert the previous into the next one. So let's try that with the next one. So now I have A4 is equal to the previous, which is 10, plus 4, which is equal to 14. A5 is equal to the previous, which is 14, plus 4, which is 18. And then my last term, A6, is equal to the previous, which is 18, plus 4, which is equal to 22. So my 6 terms are 2, 6, 10, 14, 18, 22. And you notice I am adding 4 each time, which is my common difference. Okay, let's try this next one. So now I have A1 is equal to 1 and AN is equal to 3 times AN minus 1. So I'm going to go ahead and highlight that, and remember that is previous. So that means that A2 is going to equal to 3 times my previous term, which I have as 1, which is equal to 3. A3, my third term, is going to equal to 3 times my previous term, which is 3, and I get 9. A4 is going to equal to 3 times my previous term, which is 9, and I get 27. A5 is going to equal to 3 times my previous term, which is 27, and I get 81. And then my last term, my 6th term, is going to be 3 times my previous term, which is 81, to get 243. And so my 6 terms are 1, 3, 9, 27, 81, 243. So here, my rule is AN is equal to 1/2 times AN minus 1. So 1/2 times the previous term. So my previous term here is negative 36 to get negative 18. A3 is going to equal to 1/2 times my previous term, negative 18, to get negative 9. My 4th term is going to equal to 1/2 times my previous term, negative 9, to get negative 9/2. A5 is going to be 1/2 times my previous term, negative 9/2, to get negative 9/4. And then my 6th term is going to be 1/2 times my previous term, negative 9/4, to get negative 9/8. And so my sequence here is negative 36, negative 18, negative 9, negative 9/2, negative 9/4, and negative 9/8. Okay, go ahead and pause the video. I want you to try and do that last one on your own. So the answer you should have gotten here was 8, 1, negative 6, negative 13, negative 20, and negative 27.